Hi everyone, and welcome to this video in which we will show how to make a creation of body-centered cubic unit cell with fully parameterized geometry in Rhino Grasshopper. For the beginning, we are running Grasshopper tool of the Rhino system. And what is body-centered cubic or BCC unit cell? This lattice has struts radiating from the center to the corners. It has in total 8 corner points plus one body center point at 000 or world origin. Struts, which means 8 straight lines in total connecting the body center points to each of the 8 corner points. First of all, we will define number slider component. And this component will be representing half the length of the cube's side. So we will rename it to cell size, and we will make some edits of this component where we want to use integer numbers with minimal volley of 1 unit to maximal volley of 10 units. So by the default volley, we will set a 5 units for the beginning, and also we add a negative component. Connect them to each other, and using merge components we connect these two volleys, volley D1 and volley D2. So what does it mean? It means that our future unit cell is going to have 5 units in positive side, 5 units in positive side of coordinate system, and 5 units in negative side of coordinate system. So in total it will be 10 points or 10 units of the unit size in overall. After that, we introduce construct point. This component defines 8 corners of our unit cell, but before we get 8 corners, it's crucial to include cross-reference component before construct point. We will include bifocals components to show names of each component or command in Grasshopper. This is crucial moment, as I said, because this component tells Grasshopper to create a point at every possible combination of the input coordinates, giving you all 8 corners we need for creation this kind of unit cell. So we will connect output of the merge to each input of the cross-reference, but don't forget that for this kind of unit cell we need 3 inputs of cross-reference because of 3 coordinate directions: x, y, and z direction, including positive side and also negative side of the coordinate system. But also we need, as I said at the beginning, one central point that represents world origin or absolute coordinate 0, 0, 0. So we add one more construct point, and by default, with no any inputs of this component, it will create a single point at world origin 0, 0, 0. This is here positioned, and this is our body center node, which will be connected with each dot or each point at every single of the 8 corners in total. Now we introduce a line component to join these corners, but line component that will be created between at least 2 points. First point will be center point or world origin 0, 0, 0, and second point B will be our construct point representing 8 corners of the unit cell. Grasshopper will automatically create 8 lines, each starting from the single central point and ending at one of the 8 corner points. Now we can solidify the geometry. These lines are just curves. To make them look like a solid structure, we will create pipes around them. So for that kind of adding body to this construction lines or wireframes, we will use multi-pipe component and connect it to the curves as its input. Also, we can define a strut size using panel component, and it will be the half of the 1 point or 1 unit. So here we will notice that ends of the unit cell are pretty straight. So we can include in caps option, we can choose a round option to make a roundness at the ends of the unit cell. So if we look closer, we will see that our cell size of 5 units, which is half of the unit in total, which means 5 units to positive side of coordinate system, and also this component, negative component, includes 5 units to the negative side of the coordinate system, which means that we have a unit cell in total of 10 units of this structure. So once again, we created this kind of unit cell named body centered cubic, or BCC. At the end, also we can include a solid model, baked solid model, which right click on multipipe output and select bake, and we will get a solid ready part of the unit cell. So with this workflow in Grasshopper, we created a fully parameterized geometry for unit cell named BCC, or body centered cubic, ready for the next workflows to implement it into a bigger and more complex structures like periodic uniform structures based on this kind of unit cell. That's it.